Hello, today we'll be talking about question 3.3 from the assignment we were given yesterday. So, the question is asking, a man throws a 0.4 kilogram ball into the air at a speed of 10 meters per second. Now, how fast will the ball be 1/3 of its maximum elevation? We could probably easily do this with kinematics, but instead we'll use energy. Now, I think this is actually really helpful. You should draw out the bar graph, this chart. It makes everything easier. Now, this part's before, and the second half is after. Now, what exact points are we talking about? Well, the before is, okay, even though the man is throwing the ball, the before will be just after the man threw it. If it was while the man threw it, then there would be no initial speed, because it would just be the man throwing it. So, this initial speed will be 10 meters per second. The initial kinetic energy. There's no gravitational energy. This is because we can set 0, or okay, let's just say where the man threw the ball is 0, and this means that anything above this line of 0 will have potential gravitational energy, and anything under it will have negative potential gravitational energy. This makes it easier, because now a before will only have kinetic energy, as we do not have any elastic energy, and we do not have any work, because the before is just after our before moment, is just after the man has thrown the ball. So no work is being done at this point. The after is at the max height, and at the max height, the ball is not moving, so there will be no kinetic energy. At this one point of time, the ball will not move at the very top. However, we have to have energy conserved on before and after, so there has to be gravitational potential energy. So there it is, because it is above, the ball at this point is above the 0 line we have created. Now, there's no potential elastic energy, and there's no internal change in internal energy, so these two are equal. Initial kinetic energy is equal to potential gravitational energy, final gravitational energy, or potential energy. Now, we know that kinetic energy is just 1/2 mv squared. And this is equal to gravitational force, which is just mass times mass times g times delta h. However, since delta h is just hf minus hi, and hi is 0, that means delta h is just hf, and hf is the max height, so we'll just call that h. Now, this is what we're looking for, the max height. So we can cross out m, because they're on both sides, and we'll divide g on both sides. So v squared over 2g equal to the max height. Now, we already know that the initial velocity, yeah, we should make this easier. This is the initial velocity, because we're looking for the kinetic energy, the initial kinetic energy, so the before energy. So we have to use the before velocity. So the initial velocity squared, so meters per second squared, all over 2, 9.8 meters per second squared, equal to h. Now plug this into the calculator, and you'll get that the max height is about 5.10 meters. So this is the max height. Woo, we found it. But we're looking for 1/3 of that. So I say we redraw the graph. Is it possible to cool. So now we have our graph again. And this time we're going to be looking for it at 1/3 of its when the ball is at 1/3 of its maximum height. So the before will be exactly the same, at the exact same moment. So the only energy the ball will have is kinetic energy, initial kinetic energy. Yeah. And since the Earth is in the system, there's potential gravitational energy. Since the ball is at 1/3, only at 1/3, there's not as much gravitational energy, but there's still some because it's above the 0 point line. It's around here-ish, 1/3. And since it's still going up or down, depending however you want to look at it, there's kinetic energy. So these two combined will equal that because energy is always conserved. So Ki is equal to Kf plus EGF. Okay, sorry. So, yes, we know that kinetic energy is just m mass velocity squared, but the left side is only pertaining to the initial velocity. So, initial velocity squared over 2 is equal to mv squared, but final, because this is after in this case, so final here, squared over 2 plus mgh. Since m, we can divide m on both sides, so that'll just leave initial velocity squared over 2 is equal to I shouldn't write all that. So we can take out m by dividing m on both sides. We also know that initial velocity is 10. That'll be 10 meters per second squared divided by 2 is equal to the n velocity squared divided by 2 plus 9.8 per second. Now h is equal to 1/3 of what we got, so 5.10 divided by 3 is equal to the h that we're trying to find out. So this is about 1.7 meters. Now, 50 meters per second squared. No, 50 meters squared over a second squared is equal to n velocity squared divided by 2 plus 16.66 meters squared over a second. Now we can subtract this onto the second side. So we get about 33.34. Yeah, 33.34 is equal to n velocity squared over 2. And if you multiply 2 on both sides, you get 66.6 8. And then for square root 6.68, you get about I'm getting ahead of myself. In the square root, you get about 8.2. Here's a second. Which is the velocity at the final velocity at the point of time when the ball is after, which is when the ball is 1/3 of the maximum height. Yep. I believe this is the answer. And yes, it is.